All right, good morning, guys. We are on lesson 10, multi-step experiments, on page 71. First question there, it says, are these true? Okay, so first equation, I add 4/8 together. 8 times 4 is 32, divided by 3 is 32 divided by 3, 8. And that would be, of course, false. Second one, looks like I have 50 divided by 5. Is that 10? And of course it is true. Next one, 6, 4, 6, 4, 6, 4, so that'd be 30 divided by 6. Is that 5? And yes, it is, so that is true as well. Next question says, the other day you wrote the sample space for spinning each of these spinners once. Okay, so we had a 4-sided and then a 5-sided number. See if I can find that. It's right here. So here were all my choices. There were 20 of them. What is the probability of getting a green and a 3? Okay, there is 1 green, 3 there, and that would be 1 out of 20 choices. So my probability would be 1 over 20. Okay, I'm going to also show you another way to do that. Let's do one more first. Blue and any odds. So blue would be here with an odd number would be 1, 3, and 5. So that would be 3 out of 20. And I'm going to show you another way to do that problem. If you would look at individually, okay, probability of getting a blue would be 1 out of 4. Probability of getting an odd would be 3 out of those 5. And if you multiply them together, you always get the same thing as if you'd write the sample space. Okay, next one, any color other than red. Okay, other than red, so that would be those 15. But there's also a stipulation it can't have a 2 in it. So out of those 15, this one won't work, this one won't work, that one won't work because they have a 2. So no red, so I can't include those, and no 2, I can't include those. So that's a total of 4, 4, and 4. That would be 12 out of 20. And we can divide by 4. And reduce it to 3/5. Next page. The other day you look at a list, table, and tree diagram showing a sample space for rolling a dice and flipping a coin. Okay. That was right here. We had a table, tree diagram, and a list on the previous page. This is on page 64. What is the probability of getting a tails and a 6? Okay, so we can use whatever one we want. There are 6 times 2, there's 12 choices. How many have a tails and a 6? That would be just this one. So that would be 1 out of 12. Heads an odd number. Heads an odd number. Heads an odd number, heads an odd number. So that's 3 out of 12. And then reduce it to 1/4. All right, again with that one, what's the probability of getting a heads? We can split it up and do it individually instead of looking at a list. Probability of getting a heads on a coin is 1 out of 2. What is the probability of getting an odd number on a dice? I know there's 6 choices. Odd numbers would be 1, 3, and 5. So 3 over 6 are 1/2, and then if I multiply those together, I get 3 over 12 and 1/4. So notice I get the same answer whether you look at the table or you do them individually. All right, the next chart is going to be very important. I want you to get this one in your notes. Okay, this is the total choices if you would roll 2 dice. All the possibilities if you would add them together. Okay, so this is die 1. 1 through 6, die 1, 1 through 6. 6 choices, 6 choices. So I got 36 things that can happen when you roll 2 dice. I can get a 1 and a 1, which is a 2. I can get a 2 and a 1, which is a 3. I could get a 2 and a 2, which is a 4. So those are all possibilities. I can't get anything more than 6 and 6, which is 12. Okay? So write this down. Pause it right now. Write this down. This is going to be important and save you time in the future. Okay? What is the probability of both dice showing the same number? Okay, I know there's 36 possibilities. Same number would be a 1 and a 1, a 2 and a 2, 3 and a 3, 4 and a 4, 5 and a 5, 6 and a 6. No other way to do it. That is 6 options, so 1 out of 6 chances of rolling 2 dice and getting the same number. Okay, next one. Exactly 1 cube shows an even number, so we're going to go through each one of these individually. Maybe we'll see a pattern. Okay, 1 and a 1, neither one of those is even, and it says exactly 1 cube. Okay, 2 and a 1, yes, the 2 is even, so that's a choice. 3 and a 1, no. 4 and a 1. 5 and a 1, 6 and a 1. So again, circling the ones where only 1 cube is even. Okay, here they're both even, so I'm going to skip it. And you'll notice you'll start to see a pattern of which ones work. And you don't have to circle these because you're going to use yours in the future quite a bit. So it looks like I have 3, 6, 9, 12, 15, 18 out of 36. Which you'll notice we have exactly half of them circled. Question C. At least 1 cube shows an even number. Okay, so these all work. That was 1 cube showing an even number. Now that it says at least, that means I can include 2 even numbers. Okay, so 2 and a 2 is even. 2 and a 4 is even. 2 and a 6 is even. 4 and a 2, 4 and a 4, 4 and a 6, 6 and a 6, 6 and a 4, 6 and a 2. Notice now we even have more circled, and we actually added 3 in each row of the evens. 3 in this row, 3 in the 4 row, 3 in the 6 row. So that's another 9 added on to my 18, so that's 27 out of 36. And we are going to, let's see, divide by 3. 9 over 12. And divide by 3 again. Reduces to 3 over 4. You can notice how this makes it a lot easier to get a visual for 2 dice. Okay, 2 values have the sum of 8, so I'm looking at the sum of 8s. 8, 8, 8, 8, 8. 5 of them. That would be 5 out of 36. 2 values that have a sum of 13. 2 dice cannot add up to 13, so that would simply be 0. Jada flips 3 quarters. What's the probability that all 3 will show the same side? So all 3 heads or all 3 tails. And I thought we did 3 coins. We did on page 65. Letter A. Here are 8 choices for flipping 3 coins. They did a dime, nickel, and penny. It doesn't matter the coins. Okay, so how many times did we get the same 3 things? You get 3 heads or 3 tails. So that'd be twice. Out of the 8 possible, reduce it to 1/4. Okay, imagine there are 5 cards. They are colored red, yellow, green, white, and black. You mix up the cards and select one of them without looking. Then, without putting the card back, you mix up the remaining cards. So this is the first time that we haven't put the card back. So that's key. So make sure you read the directions. So that means I can't draw 2 red, because once you draw red, it's going to be gone. Okay, so my possibilities. I could draw, it says right to sample space. That's why I'm doing that. I could draw a red and a yellow, red then a green, red then a white, red then a black. I cannot draw 2 reds because I do not put the card back. Okay, I could start with yellow. I can't draw 2 yellows, but I could draw a yellow then a red. I could draw a yellow then a green, yellow and a white, yellow and a black. Same thing with green. Green red, green yellow, green white, green black. I don't know why I put an R there. Same thing with white, white red, white yellow, white green, white black. Start with black, red, black yellow, black green, black white. Okay, that is a total of 20 outcomes. Again, we could figure that out without looking. I have 5 possibilities to draw. Now let's say I take the red out. Now I have 4 possibilities left to draw. 5 times 4 would tell me I had 20 outcomes as well. What structure did you use to write the outcomes? Okay, I just made a list. Could have done a table, could have done tree diagram, whatever you chose, just explain why you picked that one. Number 3, what is the probability of getting a white and a red in either order? Okay, so white and a red, either order, means red and white would work. So that is 2 out of 20, which reduces to 1/10. Okay, what is the probability of getting a black card either time? So a black card either first or a black card second. 4, 5, 6, 7, that'd be 8 out of 20. Divide by 4, 2/5. Okay, what's the probability of not getting a black card? So if this is a probability of getting a black card, 2/5, not getting a black card would be 3/5. And again, you could count them. It would be 12 out of 20 up here and reduce it into 3/5. What's the probability of getting a blue card? Well, there was no blue card, so that is not going to happen. Probability of getting 2 cards of the same color, not going to happen. Remember, once we drew a red card, we didn't put the red back, so it's impossible. So 0 out of 20, or just write 0. 0 divided by anything is 0. And getting 2 cards of different colors. That's going to be 20 out of 20 every time we drew, because we didn't put the card back. They're all different colors. There are no 2 the same. 100% of the time, going to happen. All right, guys. That concludes Lesson 9. Your homework is 76 through 78. We will talk to you soon. Bye-bye.